Welcome to example number 3. We have a girl that is walking along an east-west street, and we have a graph shown over here. And along the y-axis is the distance, and we'll have to make an assumption here. Let's assume that along the positive direction is east, so this would be positive 40 meters and positive 20 meters in the easterly direction. And then down here in the negative direction is going to be the westerly direction. So we're asked to find her average velocity for the whole time interval, so from here all the way to the very end. And we're also asked to find the average velocity at these, or actually the instantaneous velocity at A, and at B, and at C, and those are the main ones. Okay, let's start off with finding the average velocity. We'll call that part A. The average velocity is defined as the total displacement divided by the time interval. If you look at this, she starts here at the origin, 0, and then she ends at the origin. Although she walked away and then walked in the negative direction, her final position is actually exactly the same. So there is no displacement over the 20-minute period. So therefore, her average velocity is 0. That's for the whole trip. Okay, now, moving on to part A. We're going to need to find the velocity at point A at the instantaneous velocity. So we're going to use the displacement divided by the time. So we would draw a line that is tangent to this curve. It's a straight line in here. So really, why don't we just extend this line? And we'll get the slope for this entire line that is tangent to this point from here all the way to here. So once again, we're doing the slope of that line, which is the rise, or delta x, over the run, which is delta t. So if we use this whole segment here, that will be a rise of 40 meters and a run of 5 minutes. This will give us an answer of 8 meters per minute. That's the instantaneous velocity for point A. Okay, moving on from there, let's go on to the instantaneous velocity at point B here. So we need to find the slope along this tangent line from here all the way to there. So it's the rise over the run, but this has a 0 slope because there's no displacement. So 0 is your answer for the instantaneous velocity at point B. And lastly, let's find the instantaneous velocity along point C. So we need to take the slope of this line all the way here. So the velocity at point C would be the displacement divided by the time. And now it is going from 40 meters all the way down to negative 20. That is a displacement in the negative direction. So we have negative 60 meters divided by this time interval, which looks like it's going to be 5 minutes. And this gets us an answer of negative 12 meters per minute. And that's it for this example.